February 19, 1943, 27,000 feet above the North Sea, Second Lieutenant Robert Rosenthal gripped the controls of his B-17 Flying Fortress as the first 20mm cannon shell punched through the cockpit, windscreen, and exited somewhere behind his head. The plexiglass didn't shatter, it simply developed a fist-sized hole, with cracks spider webbing outward. Cold air screamed through the opening at 200 miles per hour, carrying with it the smell of aviation fuel and cordite. Rosenthal's bomber, Rosie's Riveters, was 3 hours into a mission against German submarine facilities at Bremen when 6 Focke-Wulf 190 fighters dropped out of the sun. They came in pairs, coordinated, professional, exactly the way Luftwaffe doctrine prescribed for attacking the American heavy bombers that had been appearing over occupied Europe in growing numbers. Since the summer of 1942, the German pilots expected what they had seen before: lumbering four-engine targets that caught fire easily, broke apart under concentrated fire, and fell from the sky trailing smoke and desperate men. They had shot down dozens of B-17s in the previous 6 months. They knew how these bombers died. What happened instead would force the Luftwaffe to fundamentally rethink everything they believed about attacking American heavy bombers. By the time Rosie's Riveters landed back in England that afternoon, Rosenthal's aircraft had absorbed over 100 bullet and cannon shell impacts. The tail gunner was dead. The waist gunner was unconscious from blood loss. 2 engines were shut down. The hydraulic system was destroyed. Sections of aluminum skin hung in tatters, flapping in the slipstream. And the bomber was still flying. To understand why this mattered, why this single aircraft's survival represented something unprecedented in aerial warfare, you have to understand what the world looked like in early 1943. Germany was confident, not simply optimistic, but genuinely convinced that American daylight bombing was a tactical mistake that would destroy itself through attrition. The Luftwaffe had spent 3 years perfecting the art of killing heavy bombers. They had destroyed hundreds of RAF Wellingtons, Stirlings, and Halifaxes during the British night bombing campaign. They had developed tactics, weapons, and aircraft specifically designed to tear apart four-engine bombers before they could reach their targets. German fighter pilots were the most experienced combat aviators in the world. Many had fought in Spain during the Civil War, gaining skills that their opponents could only dream of matching. They had flown through the Battle of Britain, the campaigns in North Africa, and the ongoing slaughter on the Eastern Front. They knew combat in a way that transcended training. More importantly, they had studied the Boeing B-17 Flying Fortress carefully. The bomber had first appeared in small numbers during 1942, flying missions from England that the Luftwaffe initially dismissed as pinpricks. Intelligence officers compiled detailed assessments of the aircraft's capabilities and vulnerabilities. The B-17, they concluded, was impressively armed but fundamentally vulnerable. Yes, it carried 13 .50 caliber machine guns, giving it defensive firepower that exceeded any other bomber in service. Yes, it flew in tight formations designed to create overlapping fields of fire that could shred attacking fighters. But the Luftwaffe had fought heavily armed bombers before. The key was attacking from angles where the defensive guns could not reach, concentrating fire on critical components, and breaking the formation so individual bombers could be isolated and destroyed. German pilots had developed the head-on attack for exactly this purpose, diving toward the bomber's nose where only the chin turret and bombardier's gun could return fire, then rolling away before the aircraft's other gunners could engage. Luftwaffe doctrine in early 1943 prescribed specific aiming points: the cockpit, where a single 20mm high-explosive shell could kill both pilots and send the bomber into an uncontrolled dive; the engines, which burned readily when punctured and would force the crew to bail out once 2 or more were knocked out; the wing root, where the main fuel tanks were located and a good burst could turn the entire aircraft into a fireball. These tactics worked. Through the fall and winter of 1942, German fighters were shooting down B-17s at rates that should have made American commanders reconsider the entire strategic bombing campaign. On some missions, losses exceeded 10% on a few nightmarish raids. They approached 20% at that attrition rate. Bomber crews would not survive their required 25 mission tours. The mathematics were brutal and unavoidable. If you lost 10% per mission, a crew had roughly a 1 in 10 chance of completing their tour. German intelligence calculated that the Americans would run out of trained crews long before they could inflict meaningful damage on the Reich's industrial capacity. This assessment was based on solid evidence. The Luftwaffe had examined wrecked B-17s scattered across occupied Europe. They had interrogated captured American aircrews. They had analyzed combat film from gun cameras mounted on their fighters. The conclusion seemed inescapable. The flying fortress was tough, certainly tougher than British bombers, but it could be killed through concentrated fire on vital systems. What the Germans did not understand, what they could not have understood, without access to Boeing's engineering data, was that the B-17 had been designed with a philosophy that no other combat aircraft had ever embodied. The bomber was not simply built to be strong. It was built to absorb catastrophic damage and continue flying. This design philosophy emerged from practical experience, not theoretical engineering. Boeing had been building large aircraft since the 1920s, learning hard lessons about what happened when structures failed at altitude. The company's chief engineer, Edward Curtis Wells, understood that bombers would be shot at, and that the traditional approach to aircraft design, making structures just strong enough to handle expected loads, was inadequate. Wells and his team designed the B-17 with massive redundancy in every critical system. The wings did not rely on a single main spar. They used multiple spars, each capable of handling structural loads if the others were damaged. The flight control cables were duplicated and routed through different sections of the fuselage so that a single hit could not sever them all. The electrical system had backups for the backups. Most revolutionary was the fuel system. The B-17 carried 2,800 gallons of aviation gasoline in self-sealing tanks, distributed throughout the wings and fuselage. Each tank was surrounded by layers of rubber and vulcanized fabric that would swell when penetrated by bullets, automatically sealing holes up to ½ an inch in diameter. The self-sealing technology had been developed by the U.S. Army Air Corps after observing that Japanese aircraft in China burned far too easily when hit. American engineers created a composite material that could stop fuel leaks, even while the aircraft was maneuvering and the tanks were under pressure from altitude changes. By 1942, every B-17 rolling off the production line had self-sealing fuel tanks as standard equipment. German fighters did not. Neither did most Luftwaffe bombers. The concept was known but considered too heavy and too expensive for widespread implementation. German aircraft designers prioritized performance over survivability, building fighters that were fast and maneuverable but would explode if their fuel tanks were hit. This difference in design philosophy would prove decisive, but in February 1943, most German fighter pilots did not yet grasp its implications. They knew the B-17 was difficult to kill, but they assumed this was simply because it was large and well-armed, not because it had been engineered at a fundamental level to sustain damage. Robert Rosenthal learned the truth about his aircraft's capabilities during that mission to Bremen. The initial attack by the 6 Focke-Wulf 190s was textbook Luftwaffe doctrine. 2 fighters attacked from 12 o'clock high, diving toward the nose. 2 more came in from 3 o'clock level, targeting the starboard wing. The final pair attacked from 6 o'clock low, aiming for the vulnerable belly where the ball turret gunner had limited traverse. The B-17's defensive gunners opened fire immediately. Tracers streaked through the sky in all directions. The top turret gunner, Staff Sergeant Michael Chen, tracked the fighters attacking from above, his twin .50 calibers hammering out 600 rounds per minute. The ball turret gunner engaged the fighters below while the waist gunners swung their weapons toward the beam attackers. The noise inside the bomber was indescribable. The roar of 1,400 horsepower Wright Cyclone engines, combined with the staccato hammering of multiple machine guns and the wind shrieking through holes in the fuselage, created a cacophony that made communication nearly impossible even through the intercom system. Then the German cannon shells started hitting. The first struck the number 3 engine, the inboard engine on the starboard wing. 20mm high explosive incendiary rounds designed to penetrate armor and detonate inside. The target, the engine cowling shredded, oil sprayed across the wing. The propeller began windmilling uselessly as Rosenthal feathered it to reduce drag. More shells walked up the fuselage. One penetrated the radio compartment, exploding among the racks of equipment and wounding the radio operator with shrapnel. Another hit the tail section, killing the tail gunner instantly when it detonated inside the cramped compartment. A third shell punched through the wing rote, passing within inches of the main fuel tank before exiting through the top of the wing. Rosenthal fought to keep the bomber in formation. The B-17s flew in tight boxes specifically so their defensive firepower would overlap, creating a killing zone that fighters had to pass through to attack. A bomber that fell out of formation was a bomber that would be swarmed and destroyed within minutes. The Focke-Wulfs made 3 passes, each time concentrating their fire on Rosie's riveters. Rosenthal counted at least 40 separate impacts. During the second pass alone, the bombardier's position took multiple hits, shattering the plexiglass nose and wounding the bombardier in the shoulder. The number 4 engine began trailing smoke, forcing Rosenthal to shut it down as well. Flying a B-17 onto engines was theoretically possible. Pilots trained for it. But flying a battle-damaged B-17 onto engines at 27,000 feet, while maintaining formation and fighting off determined fighter attacks, was something else entirely. The bomber began losing altitude. Rosenthal pushed the throttles on the 2 remaining engines to maximum power. But physics was physics. 2 engines could not generate the thrust of 4. The formation began pulling away. Rosenthal watched the other bombers slowly climb ahead as Rosie's riveters fell behind. Descending at roughly 100 feet per minute, he knew what came next. German fighters orbited bomber formations specifically looking for stragglers. A lone B-17 with 2 engines out was exactly the kind of target they hunted. But the bomber kept flying. Despite the holes in the wings, despite the shattered cockpit, despite 2 dead engines and failing hydraulics, the aircraft responded to the controls. The wings generated lift, the rudder provided directional control, the elevators allowed him to adjust pitch. Every system that absolutely had to work was still working. The waist gunner, Sergeant James Morrison, reported over the intercom that he could see daylight through dozens of holes in the fuselage. Some were small 9mm bullet holes from the Focke-Wulf's machine guns. Others were fist-sized from cannon shells. A few were large enough to crawl through. The aluminum skin looked like it had been attacked with an ice pick. Yet the fuselage was not breaking apart. The structural frames that gave the B-17 its shape were still intact. The stressed skin construction technique that Boeing had pioneered in the 1930s meant the aluminum skin itself contributed to structural strength, but the real load was carried by internal frames and longerons that the German bullets simply had not hit in sufficient quantity. Rosenthal managed to nurse the bomber back across the North Sea. The 2 remaining engines ran smoothly despite the damage surrounding them. The self-sealing fuel tanks had done their job, punctured in multiple places. They had sealed themselves automatically, preventing the catastrophic fuel loss that would have forced him to ditch in the freezing water. The landing was controlled. Chaos with no hydraulics. Rosenthal had to manually crank down the landing gear using the emergency hand pump, a process that required 2 crew members working in shifts for 15 minutes. The brakes were marginal at best. The flaps would not fully extend. But the bomber touched down on the grass runway at their base in eastern England, rolled to a stop, and shut down its engines without further incident. The ground crew counted the damage. 207 separate hits, bullet holes riddled every major section of the aircraft. Cannon shells had penetrated the wings, fuselage, and tail. 2 engines were complete losses. The radio was destroyed. The tail gunner's position looked like it had been hit with a sledgehammer, and the bomber had flown 300 miles home onto engines with all that damage. News of Rosie's riveters spread through both the American bomber groups and through interrogation of captured Luftwaffe pilots into German intelligence assessments. The story was not unique. Other B-17s were returning from missions with similarly catastrophic damage. Bombers with entire sections of wing missing. Bombers with the nose blown off. Bombers with 2 or 3 engines shot out. And they kept flying. German fighter pilots began reporting a disturbing pattern. They would make perfect attacks on B-17s, see their cannon shells exploding all over the target, watch pieces of the bomber breaking away, and then watch in frustration as the damaged aircraft maintained formation and continued to its target. Hauptmann Heinrich Ehrler, a Luftwaffe ace with over 100 kills on the Eastern Front, recorded his experiences attacking American bombers in early 1943. "We would hit them again and again," he wrote. "Pieces would fly off, we could see the impacts, but they would not go down. It was like shooting at a ghost." The Luftwaffe began compiling damage reports from interrogations and wreckage analysis. What they discovered challenged their fundamental assumptions about how aircraft should be destroyed. The B-17 did not have any single catastrophic vulnerability. Hitting the cockpit might wound the pilots, but the co-pilot could fly the aircraft. Knocking out to engines did not force it to land. Even severing control cables often left enough redundant systems that pilots could maintain basic control. Major Gunther Rall, one of the highest-scoring fighter aces in history, later described the revelation that dawned on German fighter pilots during this period. "We thought we understood how to kill heavy bombers," he said in a post-war interview. "Concentrate fire on the engines and cockpit. Break up the formation." The British bombers would catch fire or break apart, but the Americans had built something different. They had built a bomber that could absorb punishment we had never seen before. The shift in German tactics began in the spring of 1943. Luftwaffe training schools started emphasizing the need for sustained attacks rather than single passes. Fighter pilots were instructed to make multiple runs on individual bombers, concentrating fire until the target actually went down, rather than assuming a few good hits would be sufficient. New weapons entered service specifically designed to address the B-17 problem. The 30mm Mk-108 cannon replaced the 20mm MG-151 on some fighters, providing much heavier punch at the cost of reduced muzzle velocity and accuracy. A single hit from a 30mm high-explosive shell could sever a bomber's wing spar, or detonate a fuel tank even through self-sealing protection. Rocket-armed fighters began appearing, carrying tubes of 21cm Werfer granite rockets under their wings. These unguided projectiles had to be fired from close range and were wildly inaccurate, but a direct hit would obliterate any bomber regardless of how tough it was built. But even with new weapons and new tactics, the fundamental problem remained. The B-17 Flying Fortress had been designed from the beginning to survive in an environment where it would be shot at repeatedly. Every critical system had redundancy. Every vulnerable component had been armored or protected. The aircraft embodied a design philosophy that accepted damage as inevitable and built in the capability to absorb it. This was revolutionary not because American engineers were smarter than their German counterparts, but because they had started from different assumptions. German aircraft design prioritized performance speed, climb rate, maneuverability. American bomber design prioritized mission completion, even if that meant sacrificing some performance for survivability. The difference showed in the statistics. By mid-1943, Luftwaffe fighter pilots were expending an average of over 800 rounds of ammunition to shoot down a single B-17. British heavy bombers typically went down after fewer than 300 rounds. The Flying Fortress required nearly 3 times as much ammunition to kill, and even then, some bombers that should have been destroyed managed to limp home. German after-action reports from this period reveal growing frustration. Pilots described hitting B-17s with what should have been lethal fire, only to watch the bombers continue flying. Some pilots reported running out of ammunition before achieving a kill, forced to break off the attack and watch their damaged target continue toward its objective. The psychological impact was significant. Luftwaffe fighter pilots had grown accustomed to a certain rhythm in combat. Identify the target, line up the attack, press the firing button, Watch the target explode or catch fire or break apart. Against the B-17, that rhythm was broken. The final step, the satisfying confirmation of a kill, was no longer guaranteed even after what appeared to be perfect attacks. This mattered because fighter pilots operate in an environment of intense stress, where confidence is survival. A pilot who doubts his weapons or his tactics is a pilot who hesitates, and hesitation in air combat is fatal. The B-17 was introducing doubt into the minds of pilots who had previously been certain of their superiority. The Americans, meanwhile, were learning their own lessons. Yes, the B-17 could absorb tremendous punishment. Yes, it could bring crews home even after catastrophic damage. But could survive was not the same as would survive. Losses remained brutal through 1943 and into 1944. The deeper question was whether the bomber's durability could offset the Luftwaffe's skill and numbers long enough for American industrial production to overwhelm Germany's defenses. That answer would be written in the skies over Europe through 2 more years of daylight bombing, 2 years during which thousands of B-17s would take off from English airfields, and hundreds would not return. But something fundamental had shifted. In February 1943, when Rosie's riveters landed with 200 bullet holes and a dead tail gunner, but a living crew and a repairable aircraft, the Luftwaffe had learned that the American bomber they had dismissed as merely tough was actually something unprecedented, a combat aircraft designed from its first blueprint to be nearly impossible to kill. The Germans would spend the rest of the war trying to solve a problem that Boeing's engineers had created years earlier in a Seattle factory, and they would discover that some problems have no solution when your opponent has thought 3 steps ahead. Part to the evolution of Luftwaffe tactics against the B-17 Flying Fortress accelerated through the spring and summer of 1943, driven by a combination of desperation and professional necessity. German fighter pilots were facing an opponent that refused to die according to the rules of aerial combat as they understood them. Major Egon Mayer, commanding officer of Jagdgeschwader II, became one of the first Luftwaffe officers to systematically analyze the B-17 problem and develop new tactical solutions. Mayer was not simply a skilled pilot, though he was that, with over 100 kills to his credit. He was a thinker, someone who studied combat results and adjusted tactics based on evidence rather than assumption. In March 1943, Mayer compiled reports from his pilots after a series of missions against American bomber formations. The pattern was unmistakable: attacks from the rear. The traditional approach for fighter pilots engaging bombers were becoming suicide runs. The B-17's tail gunner position was too well protected, and the bomber's other defensive guns could engage fighters approaching from behind. With devastating effectiveness, beam attacks coming in from the side allowed fighters to avoid some defensive fire, but also exposed them to gunners in the top turret, ball turret, and waist positions simultaneously. Pilots were being hit before they could do sufficient damage to the bomber. The cumulative effect was that German fighters were taking casualties at rates that could not be sustained while failing to achieve corresponding kills on the American formations. Mayer's solution was radical: attack from directly ahead, head-on, into the bomber's nose. This approach minimized the time the fighter was exposed to defensive fire and concentrated the attack on the cockpit area, where killing both pilots would send the bomber down regardless of how tough its structure was. The problem was that it required nerves of absolute steel. A head-on attack meant flying directly toward a bomber that was approaching at 200 miles per hour, while you were closing at over 300 miles per hour. The combined closing speed exceeded 500 miles per hour, meaning you had perhaps 3 seconds to line up your shot, fire, and break away before collision became inevitable. Miss the timing by even a fraction and you would ram the bomber, killing yourself, along with the enemy crew. Mayer trained his pilots extensively in the new tactic. They practiced on the ground with models, calculating the angles and timing. They flew training missions against friendly bombers, approaching from dead ahead and breaking away at the last possible moment. Some pilots could not master the technique, the psychological pressure of flying directly at a multi-ton aircraft. While machine gun tracers streamed toward you proved too much. Those who could not do it were reassigned to other duties. Those who could became specialists in killing B-17s. The head-on attack debuted operationally in April 1943 and immediately proved effective. German fighters would position themselves 5 to 10 miles ahead of the bomber formation at the same altitude, then turn and dive directly toward the lead aircraft. The goal was to kill the lead bomber's pilots, causing it to falter and disrupt the entire formation's cohesion. American bomber crews quickly learned to fear the head-on pass more than any other attack profile. Pilots and co-pilots sitting behind relatively thin plexiglass at the front of the aircraft could see the German fighters growing larger in their windscreens, could see the muzzle flashes as the cannon and machine guns opened fire, could watch the tracers racing toward them in the final seconds before impact. The only defensive weapons that could engage a head-on attack were the chin turret, which many early B-17s lacked, and the Bombardier's single 50 caliber machine gun. Neither was particularly effective against a fighter pilot who knew what he was doing. The Bombardier's gun had limited traverse and was difficult to aim accurately. The chin turret, when present, was better but still provided only 2 guns against an attack that might involve multiple fighters approaching simultaneously. Yet even the head-on attack, effective as it proved, did not solve the fundamental problem of the B-17's durability. Killing the pilots worked only if you actually hit them. The cockpit was a relatively small target on an aircraft that was itself moving and maneuvering. Many head-on attacks that appeared successful with cannon shells clearly hitting the bombers' nose resulted in damage but not kills. First Lieutenant Charles Brown's experience on December 20th, 1943, demonstrated both the effectiveness of the head-on tactic and the B-17's ability to survive even when it worked as intended. Brown was piloting Ye Old Pub on a mission to Bremen when his formation was attacked by Bf-109 fighters executing textbook head-on passes. The first attack killed the Bombardier instantly when a 20mm shell exploded inside the nose compartment. The same burst wounded the navigator and shattered the plexiglass nose panels. Brown himself took shrapnel in his right shoulder but maintained control of the aircraft. The number 2 engine was hit and began trailing smoke. The oxygen system was damaged, causing several crew members to suffer hypoxia symptoms. Brown made the agonizing decision to abort the mission and turn back toward England. Falling out of formation meant exposure to follow-up attacks from German fighters who specifically hunted stragglers, but continuing to the target with a wounded crew and battle damage seemed suicidal. Ye Old Pub turned west and began losing altitude. What happened next has been documented extensively through both American and German records. A Luftwaffe pilot named Franz Stigler, flying a Bf-109 G6, spotted the damaged B-17 and maneuvered into position for an easy kill. He could see the bomber's wounds clearly, one engine out, holes throughout the fuselage, the shattered nose. The tail gunner's position appeared unmanned. It was exactly the kind of target that pilots dreamed of: vulnerable, isolated, unable to defend itself effectively. Stigler closed to within 200 yards and prepared to fire. Then he saw something that changed his mind. Through the holes in the fuselage, he could see crew members administering first aid to wounded comrades. The tail gunner was slumped in his position, either dead or unconscious. The waist gunners were not manning their weapons, they were trying to stop bleeding. Stigler had fought on the Eastern Front before transferring to France. He had seen enough death to last a lifetime. Something about watching the American crew trying to save their wounded while their crippled bomber struggled to stay airborne triggered a decision that would define the rest of his life. He did not fire. Instead, Stigler flew alongside the B-17, close enough that Brown could see him clearly through the shattered cockpit. The German pilot gestured, trying to communicate. Brown initially thought Stigler was signaling surrender, which made no sense. Then he realized the German was directing him towards Sweden, neutral territory where the crew could land safely and sit out the war as internees, rather than being killed or captured. Brown shook his head and pointed west, toward England. Stigler stayed with the bomber as it crossed the German coast, flying close formation to discourage anti-aircraft batteries from firing. Once they were over the North Sea, Stigler saluted, peeled away, and disappeared into the clouds. Brown never forgot the encounter. Neither did Stigler, though he kept it secret for decades. Assisting an enemy bomber to escape was exactly the kind of action that could result in execution if discovered by the Gestapo. The two men would not meet again until 1990, when a chance encounter at a veterans reunion revealed their shared story. The incident highlighted something that pure statistics could not capture. The B-17's durability was not simply about metal and engineering. It was about giving crews a chance to survive circumstances that would have killed them. In any other aircraft, ye old pub had absorbed damage that should have sent it into the North Sea. Yet it flew home because Boeing's engineers had built in enough redundancy that even catastrophic hits to critical systems left alternatives available. By late 1943, the Luftwaffe was compiling extensive documentation on B-17 vulnerabilities based on hundreds of combats. German intelligence officers created detailed diagrams showing optimal aiming points, weak spots in the defensive armament coverage, and the most effective approach angles for different fighter types. What the diagrams revealed was troubling. The B-17 had weak spots, certainly. The area between the cockpit and the top turret had limited defensive coverage. The belly was vulnerable from certain angles. The tail cone could be attacked with reduced risk if you accepted the tail gunner's fire. But none of these weak spots guaranteed a kill. Even perfect shooting at optimal aiming points often resulted in damage rather than destruction. The fuel system particularly frustrated German analysts. They knew the B-17 used self-sealing tanks, captured aircraft, and interrogated crews confirmed this. What they did not fully understand was how effective the technology was. German pilots reported repeatedly hitting fuel tanks, seeing fuel streaming from the wounds, and then watching in disbelief as the leaks stopped within seconds or minutes. The self-sealing process was almost miraculous in its effectiveness. When a bullet punctured the tank, fuel began leaking through the hole, but the fuel immediately came into contact with layers of untreated rubber and vulcanized fabric. Between the inner and outer tank walls, the rubber swelled when exposed to aviation gasoline, expanding to fill the hole. The vulcanized fabric provided structural support, preventing the swollen rubber from simply tearing free. Under the pressure of fuel and airflow, the system worked for holes up to ½ an inch in diameter, large enough to accommodate most machine gun bullets, and even some small cannon shell fragments. Larger holes from direct cannon hits could not be sealed, but even then, the compartmentalized tank design meant that losing one section did not necessarily result in losing all fuel. The B-17 carried fuel in multiple tanks distributed throughout the wings, and crews could cross-feed between tanks to compensate for damage. German engineers attempted to develop their own self-sealing tank technology based on captured American examples, but the material science proved difficult to replicate. Under wartime conditions, the specific rubber compounds required were in short supply. The manufacturing process was complex and time-consuming. By the time Germany could have fielded self-sealing tanks widely, resources were too scarce and production priorities had shifted to simply building more fighters, regardless of their vulnerability. The disparity in survivability became stark when you examined casualty statistics. From mid-1943 onward, Luftwaffe fighter losses over Germany were increasing dramatically as American bomber formations grew larger and escort fighters penetrated deeper into German airspace. But when German fighters were shot down, their pilots rarely survived. The aircraft would catch fire from punctured fuel tanks and burn before the pilot could bail out, or the fighter would break apart structurally, trapping the pilot inside. American bomber crews in B-17s, even when their aircraft was shot down, had significantly higher survival rates. The bomber's structure held together long enough for crews to bail out. The aircraft's slow stall speed and relatively gentle handling characteristics gave pilots time to maintain control while the crew evacuated. The sheer size of the aircraft meant that even catastrophic damage to one section did not necessarily compromise the entire structure immediately. Lieutenant William Lawley's experience on February 20th, 1944, illustrated this principle under the most extreme circumstances imaginable. Lawley was piloting a B-17 on a mission to Leipzig when his formation was attacked by German fighters. A 20mm cannon shell exploded in the cockpit, killing the co-pilot instantly and seriously wounding Lawley in the face and both arms. Shrapnel from the same explosion wounded 8 other crew members. The No. 3 engine was knocked out. The oxygen system failed. The aircraft began falling out of formation, losing altitude and speed. Lawley, bleeding heavily and barely conscious, somehow maintained enough control to prevent the bomber from entering a fatal spin. The engineer and radio operator came forward to help. They pulled the dead co-pilot from his seat, a horrifying but necessary task in the confined space, and attempted to assist Lawley with the controls. Lawley refused to bail out. Several crew members were too badly wounded to parachute safely. If he abandoned the aircraft, they would die for over an hour. Lawley flew the damaged B-17 back toward England while fading in and out of consciousness. From blood loss, the engineer read out airspeed and altitude. The radio operator helped work the throttles. Lawley somehow processed this information and made control inputs that kept the bomber in the air. They reached England. Lawley brought the bomber down through clouds with visibility near zero, broke into the clear, barely 500 feet above the ground, spotted an airfield, and landed the aircraft despite having no hydraulics for brakes and limited control authority. The B-17 rolled off the runway into a drainage ditch and came to rest with its nose buried in mud and its tail pointing skyward. All crew members survived. Lawley received the Medal of Honor. The citation specifically noted that he had prevented loss of life through extraordinary skill and determination while grievously wounded. But the broader point was that the aircraft had enabled his heroism. A less robust bomber would have broken apart or caught fire long before reaching England. The B-17's engineering gave Lawley something to work with even under impossible circumstances. Stories like these proliferated through 1944. Bombers returning with horrific damage became so common that ground crews developed a grim pride in how much punishment their aircraft could absorb. Crew chiefs would walk around freshly landed B-17s counting bullet holes like badges of honor, marveling at structural members that had been shot nearly through but were still carrying loads. The psychological impact on German fighter pilots was cumulative and corrosive. Every mission where they made good attacks but failed to achieve corresponding kills reinforced the sense that they were fighting an enemy that played by different rules. The bomber formations kept coming, day after day, growing larger as American production ramped up to levels that seemed impossible. By mid-1944, the United States was producing more than 400 B-17s per month. Boeing's factories in Seattle, Wichita, and other locations were turning out completed aircraft faster than Germany could shoot them down. The mathematics of attrition had shifted decisively. Even if the Luftwaffe maintained kill ratios in their favor, they could not offset the flood of new bombers entering service. Oberst Johannes Steinhoff, a Luftwaffe officer who survived the war and later became a general in the West German Air Force, wrote extensively about this period. "We knew we were losing," he recalled, "not because American pilots were better, they were not, certainly not in 1943 and early 44, but because their aircraft were designed to bring them home even when we did everything right. We would shoot one down and 2 more would appear the next day. It was mathematics, and the mathematics were against us." The final transformation in how the Luftwaffe viewed the B-17 came not from any single battle, but from the accumulated weight of experience across thousands of engagements. By late 1944, German training materials for fighter pilots no longer referred to American heavy bombers as particularly vulnerable or easy targets. Instead, they were described frankly as the most difficult aircraft to shoot down in operational service. New pilots were warned that destroying a B-17 typically required multiple attack runs with sustained fire. They were instructed to target specific components and sequence first knockout engines to reduce speed and altitude, then attack the cockpit once the bomber had fallen out of formation. then continue attacking until the aircraft actually went down or caught fire. Assuming a kill based on visible damage was explicitly discouraged. The Luftwaffe developed increasingly desperate measures to counter the bombers. Rocket-armed fighters became more common despite their poor accuracy. Some pilots attempted ramming attacks, deliberately colliding with bombers after bailing out a tactic that was exactly as suicidal as it sounds. Jets entered service in limited numbers, offering speed advantages that allowed them to make multiple attack passes. But even the Mi-62's heavy cannon armament did not guarantee kills against B-17s. Nothing worked consistently. The fundamental problem remained unsolved. Boeing had created an aircraft that embodied a different philosophy of air warfare, one where completing the mission mattered more than any other consideration. And that philosophy had been welded into every frame and rivet. The disparity became quantifiable through German records compiled after the war. Luftwaffe fighter pilots expended an average of over 1,000 rounds of mixed ammunition machine gun bullets and cannon shells to achieve a confirmed B-17 kill in 1944. This compared to fewer than 400 rounds required to shoot down British heavy bombers and roughly 600 for the B-2 for Liberator, the other major American heavy bomber. The difference was not merely academic. Ammunition weight was a critical factor in fighter performance. A fully loaded Focke-Wulf 190A8, one of the primary bomber-destroyers in Luftwaffe service, carried only 500 rounds for its 13mm machine guns and 250 rounds total for its 20mm cannon. Against B-17s, that ammunition load was often insufficient to guarantee even a single kill. German pilots learned to pick their targets carefully. Focusing on bombers that already showed damage from previous attacks, they learned to break off attacks when ammunition ran low rather than pressing home with insufficient firepower. They learned, in other words, to treat the B-17 with respect, bordering on fear, a profound shift from the confidence of early 1943. The final irony was that the Luftwaffe's increasing effectiveness against B-17s through improved tactics and weapons came too late to matter strategically. By the time German pilots had truly mastered the art of killing the flying fortress, American escort fighters had solved the problem from the other direction. P-51 Mustangs with drop tanks could accompany bomber formations all the way to targets deep in Germany, engaging Luftwaffe fighters before they could reach the bombers. The German fighter force was ground down through attrition, fighting not just against bombers, but against increasingly skilled escort pilots flying aircraft that matched or exceeded Luftwaffe performance. Experienced German pilots were killed faster than they could be replaced. New pilots entered combat with insufficient training and died within their first few missions. The quality of Luftwaffe fighter opposition declined precipitously through late 1944 and into 1945. But even in the final months of the war, when Germany's air defenses were collapsing and bomber losses had dropped to minimal levels, the B-17 remained difficult to kill. There are documented cases from March and April 1945 of individual flying fortresses absorbing over 100 hits and returning to base. The aircraft's fundamental survivability never changed, even as the circumstances around it transformed completely. After the war, American and German veterans compared notes in what became an unexpected dialogue between former enemies. Luftwaffe pilots expressed genuine admiration for the B-17's engineering. They acknowledged that fighting against the flying fortress had forced them to develop new tactics and weapons that they had never needed before. They admitted, sometimes reluctantly, that the bomber had been a more formidable opponent than they had initially believed possible. American veterans, for their part, credited the B-17 with saving their lives. Crew members who had brought home shot-up bombers spoke reverently about the aircraft's ability to keep flying when any rational assessment said it should have crashed. Flight engineers marveled at systems that continued functioning despite catastrophic damage. Pilots praised handling characteristics that remained manageable even with multiple engines out. And major structural damage. The legacy of the B-17's durability extended beyond World War II. Post-war aircraft design incorporated lessons learned From analyzing what made the flying fortress so difficult to kill, redundant systems became standard in military aircraft. Self-sealing fuel tanks became universal. Structural design emphasized damage tolerance, the ability to maintain integrity. Even when portions of the structure were compromised, the bomber itself passed into legend, its name synonymous with toughness and reliability. Of the 12,731 B-17s built during the war, roughly 4,700 were lost in combat. That meant nearly two-thirds survived the war despite operating in the most hostile environment imaginable: daylight skies over heavily defended German territory where hundreds of fighters and thousands of anti-aircraft guns waited to destroy. Then the transformation in German perception was complete. What began as dismissal of American heavy bombers as merely tough but killable targets evolved through hard experience into recognition that the B-17 represented something unprecedented. In aviation warfare, it was not simply a bomber, it was a flying statement of design philosophy, a manifestation of American industrial might and engineering expertise that could not be overcome through superior tactics or pilot skill alone. The Luftwaffe never stopped calling them prey. That was what bombers were, by definition. But they stopped calling them easy prey sometime in the spring of 1943, after enough fighters had emptied their guns into B-17s that kept flying, after enough German pilots had watched in frustration as bombers they had hit perfectly continued toward their targets, after enough impossible survivals had accumulated to prove that Boeing's engineers had created something genuinely revolutionary. In the end, the B-17 Flying Fortress earned its name not through any single dramatic moment, but through countless unglamorous survivals. Every bomber that brought its crew home, despite catastrophic damage, validated the design philosophy that had created it. Every pilot who landed a shot-up B-17 safely demonstrated that American engineers had understood something fundamental about aerial warfare that their opponents had missed. The fortress flew, the fortress fought, and against all probability, against all reasonable expectations, mission after mission and battle after battle, the fortress survived. That survival changed how the world thought about building aircraft for war. And it began with one simple truth that the Luftwaffe learned the hard way: you can shoot a B-17 100 times, and it might still bring its crew home.